Let's name regressions, regressions, regressions. Let's name regressions of data science. Right off the bat, I just want to make sure we're all clear that I'm making this for non-technical people. That means people that don't work in data science, people that don't work with math, people that hear the term AI and think it's magic. So for those who are not technical, keep in mind, AI is not magic. Write that down. AI is not magic. Okay. My goal with making these is to demystify the concept of AI because all these tech bros and billionaires keep pushing it and they try to convince us that it's this really cool thing, and while yes, it can be a tool, it's not going to solve everything. I will be oversimplifying concepts and not digging into the weeds, so if you're one of those people where that makes you cringe, this might not be for you. Just want to make sure before we move on, AI is not magic. Do we all got that? Okay, yeah, I think I do. If we break this down into very simple components, we start with data. That data gets run through logic and equations, however that looks, and after that it creates output. Machine learning is part of AI, and so to give sort of a general overview of kind of what that process can look like, you have all this data and it goes through all these different logic and equations, and you're looking for a certain output. And basically you're taking all this data and you're training this to go for a certain output. Making sense so far? AI is not magic. Perfect. I'm going to end this video on a couple of regression models that can be used within an algorithm. The first one I'll discuss is logistic regression. Basically, if something is a cat and if something is not a cat. So what happens is we have data. That data gets fed into this logic or equation, and then the output determines whether or not it is categorized as a cat or it is categorized as not a cat. Let's say we have a couple categories though. We can use something called k-nearest neighbor, where you get data, that data goes through whatever logic or algorithm it is, and then we get the input of whether or not it is a bunny, a dog, or a cat. So if we're taking in data and we're looking at the logic or equations to adjust them in order to ensure things get categorized correctly, we might look at the difference between a bunny and a dog and add things like shape of the ears. The end goal being that you want to try and fine-tune this to be as accurate as possible. In the next one, I'll discuss a couple more models as well as some of the complexities involved with this. And remember, AI is not magic.